In this example, we need to determine if this integral is convergent or divergent. As you can see, this integral is improper integral. It's improper because it's defined on the infinite interval. So limits of integration are from 0 to infinity. To evaluate this integral, we have to rewrite it the following way. So we're going to say limit as t goes to infinity. And now instead of this infinite upper limit, we're going to place t. So from 0 to t. 1 over 4th root of 1 plus x dx. And the steps will be first to evaluate this integral and then apply a limit. This integral is going to be convergent if this limit exists and it equals to a finite number. Now this integral will be divergent if this limit does not exist or it equals to infinity. So we'll see. So as I said, the first step is going to be to evaluate this integral. I'm going to do it down here, kind of like on a side. So integral from 0 to t, 1 over 4th root of 1 plus x dx equals. To evaluate this integral, looks like we'll have to use the substitution rule. Now, since it has limits, for now I'm going to rewrite it without the limits. I will evaluate it, I'll apply a substitution rule, and then I'll put everything back over here and evaluate it at 0 and t. So here's my substitution. U is 1 plus x. That's u inside the 4th root. And that means that du is simply dx. So dx I will replace with du. So I'll have integral of 1 over 4th root of u du. That is the same as the integral of 1 over u to the power 1 over 4 du. And then that is the same as u to the power negative 1 over 4, right? Now I'll just apply the power rule. So I have to add power 1, negative 1 over 4 plus 1. That's same as 4 over 4. So that's 3 over 4. U to the power 3 over 4 divided by 3 over 4. So that's 4 over 3 u to the power 3 over 4. And now u is 1 plus x. So 4 over 3 times 1 plus x to the power 3 over 4. So that's the result of this integral. And I'll place it back over here, no, right here, so that I can evaluate it. So we got 4 over 3, 1 plus x to the power 3 over 4. That has to be evaluated at t and 0. Even though we don't have a constant here, so it's just t, right, as a variable, we're going to treat it same way. So I'll just plug in t for every x in my expression here, and then I'll plug in 0 and find the difference, right? So first I'm starting with the upper limit. So every x is being replaced with t, so it means that just over here, 4/3, 1 plus t to the power 3 over 4 minus 4 over 3 times 1 plus 0 to the power 3/4, like that. Here, if I simplify it a little bit, I'll get 4/3. I'll just keep it like that, like all the powers 3/4 minus here, it's 1 to the power 3/4. It's still 1, so it's just minus 4/3, right? So we just evaluated. So what is the result? This is the result of this integral, right? Right here. We evaluated it. So it means that as I continue, I'll have to say we need to find a limit as t goes to infinity of the expression, well, of this resulting expression. I'll copy it. 4/3, 1 plus t to the power 3/4 minus 4/3, like that. And one way to determine the limit, or at least like that's something that it's always good to start with, is to just plug in limit in this expression. Plug in limit for every variable. Well, I have variable here, so it's going to become 4/3, 1 plus infinity to the power 3/4 minus 4/3. And then we need to try and see if we can find the result. There are some operations that with infinities that we can do, and there are some operations that we cannot, so we have to be careful not to do any unallowed operations. But in this case, what we have is infinity plus 1. Well, infinity plus a constant, it's always infinity, so this part is infinity. Now, infinity raised to any power that's greater than 0, infinity raised to any positive power, it's always infinity. So all that is infinity. Then infinity times any constant is still infinity. So in other words, all that is the infinity. And then infinity minus or plus any constant, it's still infinity. So long story short, we end up with an infinity here as we try to evaluate this limit. And since we ended up with infinity as a result of this integration, it means that this integral is divergent. So infinity means that the integral is divergent. So the answer will be divergent.